Have you ever looked at someone you once couldn't stop thinking about and felt almost nothing? Not dislike, not anger, just neutral. Like the volume turned down on a song you used to play on repeat every night. You didn't choose that, your brain did. And it's been doing this to your lovers, your favorites, your obsessions for a very, very long time. But here's the part that's easy to miss. That feeling, the one most people call falling out of love, isn't a feeling at all. It's a timer. A chemical timer set somewhere in the middle of your skull, ticking down whether you noticed or not. Built by an ancient system that never got the memo that you settled down, picked a partner, and bought the couch. So think back, not to the breakup, to the moment before it. The moment you caught yourself noticing someone new. A stranger on the subway had a laugh that pulled your attention half a second longer than it should have. You probably told yourself it didn't mean anything. And you were right. And you were wrong. It meant exactly what your brain wanted it to mean. Here's what's actually happening. When you first fall for someone, your brain lights up like a slot machine. Dopamine floods the reward centers, the same regions that light up for cocaine, for sugar, for the first sip of cold water after a hard run. Norepinephrine keeps your heart doing that fluttery thing, that almost nauseous little tightness in your chest. Phenylethylamine, PEA, the molecule behind chocolate hype and 1,000 love songs, gives you the racing thoughts, the lost sleep, the obsession, the way your phone can be 2 feet away and you still feel it through the mattress. Sound familiar? It's not a metaphor. It's pharmacology. Your brain is treating this other person like a hit of the most powerful drug your own body can make. And like every hit, the dose starts to fade. Not because the person got less interesting, because the receptor sites are saturating. Tolerance. Pure biological tolerance. Helen Fisher, a biological anthropologist at Rutgers, put people who had just fallen madly in love into a brain scanner and watched what lit up. Then she tracked down couples who had been together 25 years and put them under the same magnet. The reward centers were still glowing, but the pattern had changed. Long-term love wasn't the high anymore. It was something quieter, a different chemical, a different architecture. Fisher broke love into 3 rough stages: lust, attraction, attachment, each running on its own hormonal cocktail. Lust on testosterone and estrogen, attraction on dopamine, norepinephrine, and that phenylethylamine you already met, attachment on oxytocin and vasopressin. The honeymoon phase, the can't eat, can't sleep, can't think about anything else phase, that's stage 2, and it has a shelf life. Roughly 12 to 18 months, sometimes longer, but never permanent. The body doesn't have the chemistry for permanent. Most people read the fade as a verdict. It isn't. The drop-off isn't a failure. It's not your relationship failing. It's your brain succeeding at exactly what it evolved to do. Millions of years of mammalian history wired your nervous system to pursue novelty in mates, new genetic material, fresh combinations, the biological imperative hiding behind every sigh of boredom you let yourself feel. That instinct has a name. It's called the Coolidge effect, named after an unflattering moment in a presidential tour of a chicken farm when Calvin Coolidge's wife reportedly asked why the roosters kept mating, and the guide explained they did so with each new hen. "Tell that to the president," she said. The president, when told, asked the same question back. The story made its way into a 1955 paper by the comparative psychologist Frank Beach, and the effect took its name. When an animal has mated to satiety with one partner, it loses interest until a new partner appears. Then the whole cycle resets. Dopamine spikes, norepinephrine floods. The courtship ritual begins again. Your brain still has that circuit, right now, as you listen. It is there, sitting behind your planning and your restraint and your good intentions, quietly scanning for the new. But humans aren't rats. Most of you aren't out there resetting the cycle every weekend. The machinery underneath, though, that's the same. Larry Young, a neuroscientist at Emory, spent decades studying a tiny rodent that behaves nothing like the rest of its kind. The prairie vole, small, furry, fiercely monogamous, mates for life, grieves when its partner dies, chooses its mate over a stranger, again and again, even when the stranger is offering itself freely, and its cousin, the meadow vole, genetically nearly identical, raised in the same lab, fed the same diet, behaves the opposite way, promiscuous, solitary, no pair bond at all. So Young went looking for the difference. He found it in receptor distribution. Prairie voles have dense oxytocin and vasopressin receptors in the reward centers of the brain. Meadow voles have almost none. Same hormones, different wiring, different outcome. And here's the part that should make you pause. That wiring isn't fully under your control. Variants in the genes for these receptors, AVPR1A, which shapes how strongly vasopressin anchors a bond, and OXTR, which governs how deeply oxytocin lands, show up in study after study as predictors of pair bonding strength, of how strongly you feel attached after the dopamine fades. Some humans land closer to one end of that spectrum, others the other. Your pattern of attraction, the way you fall, the way you stay, the way you leave, was being laid down before you ever met anyone, before your heart ever broke, before you knew it could. So what's actually changed since this video started? A few minutes ago, you thought the honeymoon phase was a feeling? Something emotional. Something you could hold on to if you tried hard enough. Now you know it's a phase, a stage, a chemical event with a beginning, a peak, and a quiet drop. And the love that comes after, if it comes, runs on entirely different fuel. Asking the early relationship brain to keep going is like asking a struck match to stay lit forever. The flame isn't the problem. The expectation is. Here's what that looks like on a Tuesday night. The dopamine spike that made your partner feel electric slowly flattens. The first time they texted, your pulse jumped. Now their name on your lock screen feels like a notification, not an event. Oxytocin, the cuddle hormone, the molecule that floods during orgasm, during childbirth, during a long hug at the airport, takes over. Vasopressin, its quieter sibling, deepens the bond. Patterns of recognition set in. You start to finish their sentences. They know which mug you reach for. You stop getting butterflies. You start getting calm. And that calm, if you weren't expecting it, can feel a lot like nothing, like the absence of love. That's not the spark dying. That's attachment setting in. The nervous system trading fireworks for warmth. And if you mistake one for the other, if you chase the spark when what your brain is actually offering is something steadier, you'll spend your whole life confusing the afterburn of a chemical spike for the absence of love. Worse, you'll mistake the novelty circuit, that ancient, innocent Coolidge current, for a sign that you picked the wrong person, that you'll never be satisfied, that something is broken in you. There is nothing broken in you. There is something working exactly as designed. But here's what's interesting. The long-term couples in Fisher's scanners, the 25-year ones, didn't show a blank reward system. They didn't show absence. They showed activation in the same dopamine regions as the newly in love, just differently. Like a different key playing the same song. The brain hadn't fallen out of love. It had changed the key. And those couples lit up regions associated with empathy, with calm, with the suppression of negative emotion. The brain was actively choosing to stay. The reward wasn't novelty anymore. The reward was the partner. Specifically, this partner. The history, the shared memory. The way their hand fits the curve of your shoulder in the dark. Here's what nobody talks about. The Coolidge effect isn't a moral failing. It's not a verdict. Most of you will never act on it. Most of you will spend a whole lifetime in a relationship and feel the circuit hum once, in a checkout line, at a wedding, on an elevator, and then go home. The point isn't that you will leave. The point is that you now understand what that hum is. It's not your heart saying no to your partner. It's your brain saying yes to a feature it didn't ask you permission to install. That person you looked at once and felt almost nothing for. The one who made you wonder if you'd ever really loved at all. Your brain hadn't stopped loving. It had just finished one chapter and started another. The timer didn't run out on the relationship. It ran out on the phase, and the phase was never meant to last forever. The love after it, the slow, quiet, less dramatic kind, was always waiting on the other side. You just have to learn to recognize it when it shows up, because it doesn't arrive like a slot machine. It arrives like a Tuesday night, steady, familiar, yours.